In this question, we're asked to write the net ionic equation for the reaction that is taking place here. And in the process, we're also going to identify the spectator ions. So here we have FeBr3, and it's aqueous. So anything that's aqueous is going to break up in solution. So we need to write it as its ions. I'll do this one example to remind you how to calculate the charge on iron if you may have forgotten how to do that. So here we have Fe plus 3 times minus 1, so the charge on iron, plus 3, because there's 3 bromines, times the charge on bromide, which is negative 1, equals 0, because all ionic compounds have an overall 0 charge. Fe minus 3 equals 0. Fe equals 3 plus, or mathematically plus 3, but the charge is 3 plus. So this breaks up into its ions. Fe3 plus aqueous plus 3Br minus aqueous. Potassium hydroxide. Hydroxide is a polyatomic ion that's minus charge. Potassium is 1A, so it's plus 1 charge. So plus 3K plus. Aqueous plus 3OH minus aqueous. Notice, since I have 3KOH, I have to get 3K plus and 3OH minus. So these are all of the ions on the reactant side. On the product side, which I'm going to start writing over here, but you would normally start writing it here, I'm just going to run out of space if I do that, is FeOH3 solid. Notice, this is not aqueous, so this does not break up into its ions. We didn't break this one up. Plus 3K plus, we break this one up because it's aqueous. Aqueous plus 3Br minus aqueous. So everything that was aqueous, these three things, we broke up into their ions, like so. This is what is called the total ionic equation. So now we need to cancel out things that are both on the reactant side and the product side. So the first thing I notice is bromide. There's 3 bromides on both sides. The next thing is potassiums. There are 3 potassiums on both sides. And what's left, the net ionic equation, Fe3 plus aqueous plus 3OH minus aqueous yields FeOH3 solid. The spectator ions are the things that we canceled out. So potassium plus is a spectator ion, and bromide is a spectator ion. Another way to do this that's probably a little bit faster, but it's a good idea to practice doing it this way, especially if you're ever asked for the total ionic equation, is to identify the product that is a solid. So here we have FeOH3 solid. So this is a solid. Well, what ions, because everything is ions on this side because both reactants are aqueous, what ions are required to make this? Well, the first one is Fe3 plus aqueous and OH minus aqueous. But because it's FeOH3, we need 3OH minus, and since the original equation was balanced, we do have the 3OH minus. Notice these are the exact same answer, I just did them a little bit differently. Another thing that may come up is, how do you identify spectator ions? Well, there are things that are aqueous on both sides of the equation, but if you look in most double displacement reactions like this, everything is aqueous on the reactant side. So compounds that are aqueous, or ions that are aqueous on the product side, tend to be the spectator ions, which in this case, K plus and Br minus, the same ones that we canceled out. So as you practice this, you may see some more efficient ways of solving these problems.